Hello students, today we will see the nature of a magnetic field which is produced by solenoid. We all know the nature of a magnetic field which is produced by a single loop of a wire. This is a single loop of a wire, and using right hand thumb rule we can find that the magnetic field produced around the loop of a wire has this type of nature. So a single loop of a wire produces a magnetic field. So what is a solenoid? Solenoid also consists of large number of loops. This is a single loop. Solenoid consists of large number of turns of wire in the form of a loop, or solenoid consists of a large number of loops or a collection of large number of loops made up of insulated copper wire. Now this solenoid or these loops of wire are wound around an insulated surface. They are wound around insulated surface, and you can see here this is a solenoid having large number of turns, and this is a cell or a battery, and we have a switch. So when we switch on the battery or a cell, it produces a magnetic field around it. The solenoid produces a magnetic field around it. But how to know the direction of a magnetic field? Because every magnetic field has got a direction. So solenoid also produces a magnetic field. Then how to find its direction? Yes, we can find the direction of the magnetic field using a clock rule. According to this clock rule, according to this rule, let us see this rule. What is this rule? According to this rule, the loop in which direction of current is clockwise, it forms south pole, and the loop in which the direction of current is anti-clockwise forms a north pole. I repeat, according to this clock rule, the loop in which the direction of current is clockwise forms a south pole, and the loop in which the direction of current is anti-clockwise forms a south pole. Now if you observe this carefully, we get the direction of the current in this loop is clockwise. So which pole will be formed at this end? Yes, south pole will be formed at this end. If you look at this end, which type of current is flowing at this end of the loop? Is it a clockwise or anti-clockwise? If you look like this, it is a anti-clockwise. The current is going from back and it is coming in front, so it is a anti-clockwise. So which pole will be formed here? North pole. So whenever anti-clockwise, the current flows in anti-clockwise direction, it forms a north pole, and whenever current flows in the clockwise direction, it forms a south pole. So what will be the direction of the magnetic field? North pole to south pole. Yes, so the direction of the magnetic field around the solenoid will be from north pole to south pole, and this is how we can find the direction of a magnetic field around a solenoid. Wait, now we can also increase the strength of the magnetic field of a solenoid by various things. Like if you increase the number of turns, we can increase the strength of the magnetic field. We can increase the strength of the magnetic field if you increase the current flowing through the solenoid. And the third way by which we can increase the strength of the magnetic field, by putting a core inside the solenoid. So there are three ways, or we can use a soft iron core. If you put a soft iron core inside the solenoid, then the solenoid gives rise to a stronger magnetic field. So once again, I would like to tell you that solenoid produces a magnetic field which is similar to the magnetic field produced by a bar magnet. Here we can see, suppose if this is a bar magnet, if this is the north pole and this is the south pole, then the bar magnet also produces a magnetic field around it, and its direction is from north pole to south pole. In the same way, solenoid also produces a magnetic field in which the direction of magnetic field is from north pole to south pole. And the strength of the solenoid can be increased, strength of the magnetic field of the solenoid can be increased by increasing number of turns, by increasing the value of current, and by putting a soft iron core. Thank you.